I am Brad Keelor. He is Lisheng Shao. Next up on Director's Cut, find out the furthest he's ever gone out of his comfort zone and what came out of it. Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every 7 days, every single week, I sit down with a different GI member who has so many stories to tell you. Some of them are personal, some are professional, but all of them, we put our seal on it. We guarantee they are all fun. If you don't know anything about the Geo-Institute, after you watch this today, head over to geoinstitute.org, and there you will find out a lot of things, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. If you like what you see today, and I truly hope that you will, viewers, I have faith that you will, I think you will, I always believe that you will, but if you do, you know what to do. Click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Now, our guest for today, coming to us from the left coast of America, where he is the chief engineer of ground improvement at Malcolm Drilling in San Francisco. It is Lisheng Shao. Lisheng, welcome. Thank you for doing this.
Thank you, Brad.
We are going to have a great time today. We have 10 questions for you, the same way that we do for everybody every week. And 2 of them are the same that we ask every single person that comes on the show. We start with one of those. Describe your job in 45 seconds.
Sure. I'm Lisheng Shao. Grew up in China and get my undergraduate education in Beijing, Tsinghua University. Actually, my undergraduate major is engineering mechanics. A lot of theoretical calculations, mathematics, elasticity, and finite element. So build up some kind of a good fundamental trainings in the numerical analysis modeling. Actually, I get involved to the structural engineer in my graduate school in US, and again my master's degree in South Dakota School of Mine. And from there, actually, I learned some soil mechanics, and also get my PhD degree in NC State and Professor Roy Borden. And that's really eye-opening. Led me to understand this the science part of the geotech engineering, and also the art, get the experience and mentorship from the professor, and also later on through the work. After I get my PhD degree in NC State, I joined Hayward Baker, worked over there almost 25 years. And later on joined to Malcolm Drilling 3 years ago. So my work is, lots of fun. To always focus on some of the design, research, and development of the technology. And also through the work learned, every site, every job is different. And that different really kind of get more excitement, and we have more things to explore. Frequently, I make an analogy of our geotechnical work, more like a doctor treat patient. The doctor cannot standardize the patient, and for the geotech engineer, we cannot standardize the soil. So that's kind of the fundamental difference between us and the structural engineer. So that's kind of my experience in the past.
So I have to ask you about the engineering mechanics, because I know there are a lot of people out there who hear that phrase and their eyes glaze over and they say, but I'm a practitioner. What do I need to know about that? That's just math. Why should people not be intimidated by engineering mechanics?
Well, actually, that's the fundamental, that's the fundamentals of soil mechanics or soil dynamics. When we try to explore, for example, pile-soil interaction during the earthquake, we really need to understand what is the true mechanics, right? It's a string compatibility between the column, the pile to the surrounding soil, and how this kind of a failure happens. Certain kind of situation, people talk about progressive failure mode. So if you consider the whole pile group, it's possibly okay. But if you have one defect pile under a certain kind of location, it could fail one by another one by another one. So engineering mechanics provides this knowledge and also tools to solve this kind of question, especially in the sophisticated loading conditions.
So that's perfect. People shouldn't be afraid because they wouldn't be able to do their job without it. I think that's the summary there. Now, we have a lot of fun questions that we have to ask on Director's Cut 2, and we get right to those usually with question number 2. Lisheng, what is your worst habit while you're driving?
Well, this may not be, what can I say? May not be recommended for the young engineer in our industry, but as a person, I always want to do the multitask. Join the conference calls, to make phone calls, thinking, and certain time even answer some text message. Maybe kind of later on, couple of years down the road, could be legalized when we have more automated car and use AI to help us in driving. So
but it's
that's
true.
kind of bad habit may be legal in the near future.
I think you're right about that, though, because right now, I look back to when I was in undergrad in the late 90s, and the talk-to-text things had really just gotten mainstream, and every PC manufacturer started putting these on their computers. And I think a lot of us students thought, in a couple of years, I won't have to type my papers anymore. I'll just speak it, and it'll all happen. Well, I feel like the technology hasn't improved that much in the last, 25 or 30 years since we were doing that. But it does always feel like we're right on the brink of it getting good enough to be able to use. Do you use any of that stuff in the car now? Like, do you ever use the speaking thing that'll text people back? Because, you'll get a little pop-up that says someone used Siri to text you. I have never been able to do it. It makes too many mistakes with my voice. Have you ever tried it?
Yeah, I tried, and I use Google, and also certain time I use Siri, and but there's still some certain kind of the restrictions. Yeah. But I believe when we now get a level 4 or level 5 automated drive software, maybe in the near future we can do it. And also very important things, we stretch this kind of the concept. And also I'm a believer, we will have automated drill rig before the fully automated car on the street. Because, it's more certainties and the less variables for the drill rig and the drilling condition.
I like that. I tend to agree with you on that one too, just also because of the fact every single person in America, even if they don't have a driver's license, has to interact with cars on a daily basis. And when you bring that up, people freak out. Like it really gets a lot of passion from people, either for it or against it. And I think something that's industry specific, like a drill rig in that case, a lot of people might not even notice, and they just view it from afar and they're kind of like, wow, that's cool. When will that technology come to other areas? But the cars, that gets a lot of that gets a lot of passion.
Well, the car itself actually is more reliable than human beings. The most dangerous things actually is human behavior, especially when you drive the cars or the other driver. That is a major hazard. Yeah, but when to run the drill rig, we target it on the soil. So we have a proper designed installation procedure, well-known soil profile. The automated drill rig actually is much easier. Nowadays, even like in soil mixing or the residue inclusion type of the production, it is pretty much nearly automated. The driller push a few buttons, and then, the drill rig will get the job done.
That's great. So the third question that we ask is always the research or practice question. We get a little bit of luxury today with you because we get a little bit of both, the research and practice in here. You're a ground improvement guy. So I think we should maybe start with some of the different projects you've worked on with academia. I know you mentioned some work that you've done with UC Davis before we started recording. If you want to talk about that a little bit and then eventually maybe move over to some of the different ground improvement technologies that you work on day to day.
Sure. As a ground improvement engineer, especially when we work on the design, we really need to know what is the real mechanism of the element, how is the behavior of your ground improvement interact with the soil, and also understand its failure mechanism. Take an example, I was heavily involved in the research of the stone column shear reinforcement for the soil liquefaction mitigations. In earlier time, we use this string compatible type of the shear reinforcement, assume the stone column during the earthquake, and the stone column move in the same phase as the surrounding soils. But actually it's different. The higher of this column to the soil shear modulus ratio, the higher incompatible of this shear strain of this movement during the earthquake. So there was quite intensive research conducted by a joint effort of Ross Bongi and his graduate student in UC Davis, and also Professor Ogama in UC San Diego, and also Scott Ashford in Oregon State. We have a joint research trying to investigate this kind of a discrete column, like stone column, like a soil mixing column, how it kind of a behavior during earthquake, what is a failure mechanism. So it was quite quite a kind of eye-opening after this universities and the graduate students and professors run the 3D finite element model. And we find, the column during the earthquake not moving in the same phase as the surrounding soils. So the previous string compatibility maybe overpredict this kind of the function, the reinforcement effect. The higher of the modulus ratio between the column to the surrounding soil, the more string incompatible. And also when we move to the more rigid material, like a soil mixing, like a concrete columns, this string incompatibility is more intense. When you push to the extreme, like a residue inclusion, the discrete columns are reinforced in the earthquake. That column will fail in the early time at the beginning of the earthquake, because the concrete failure string at the 0.3%, while the soil cyclic shear during the big earthquake could a few percent. So by that kind of high strings, for sure, the concrete column already failed. So understand this mechanism is critically important for the design engineer to do the proper design, avoid any of the severe mistake. So a kind of a knowledge of this behavior of the mechanics behind this everyday design practice, I think is very important.
So now to follow up on that, what are a couple ground improvement technologies that you work on day to day with Malcolm?
Well, I do a lot of work, design work, the building and the construction to the stone columns and soil mixing and rigid inclusion, compaction grouting, quite a lot. Because, each job is different.
Yeah.
Like doctor treat patient, we need to read and understand the site geotech report and pick up the optimized solutions. And then when we use a stone column, mainly for the densification in the granular soil, and when we use soil mixing, typically a cellular pattern to provide the shear reinforcement. And that's kind of my pretty much everyday work. Yeah.
Oh, that's good.
But again, we need always case by case. There's no universal solution.
It's a good menu, and I have to say, I always say it every time his name comes up. I don't think anyone has been mentioned on Director's Cut more than Ross Boulanger. So it seems like every 6 or 8 weeks he comes up. It's been a little while, but here he is back again. So shout out Ross Boulanger. The question that we teased at the beginning of the interview here was about you stepping out of your comfort zone. And that's the question. Lisheng, when did you step furthest out of your comfort zone, and was it worth it?
Well, I think, the things we learned from college, from the graduate school, always benefit. So my fundamental belief is, Tazarki always right, seed address always right, Ross always right, because they establish these fundamentals of the theory, the soil mechanics and soil dynamics. This guide us to learn the site. However, the site is different, and also so many things we don't know, and we under the site actually base the indirect test, FPT, CPTs we use that correlate to the soil properties. And that's more like a doctor treat patient, right? Measure the EKGs to see what is the electric wave kind of a beating of your heart. From there, indirectly interpolate what is the soil or the human behavior or the human disease. So do as a geotech engineer. I was so lucky in my career, mentored by Roy Borden, my PhD advisor, mentored by Francis Garlardi, George Burke, in Hayward Baker. So they guide me to learn, and also guide me to handle the things I really don't know. The kind of fun things related of my early career in the dam grouting work, like Bennett Dam and Women Dam. I arrived at Bennett Dam in the winter time of 1996. Yeah, arrived over there, I realized Rob Pack was there as a project engineer. So everybody else called them as a field engineer. So learn a lot. So use the compaction grouting to fix some of the sinkholes observed on the dam crest. That's a 400 feet tall earth dam. So the tallest in Canada. And found the sinkholes are too many unknowns, right? And also to avoid hydrofracture, we cannot introduce additional drilling fluid. So the conventional SPTs is very difficult to perform. So instead, we use compaction grouting. You pump the high mobility, the very low mobility grout. Based on this cavity expansion, you use that indirect to understand and learn what's the damage inside the dam and where. So we run the primary, secondary, tertiary pattern until we densify this chimneys and this sinkhole-related damage. So after that, in year 2000, I went to South Korea, participate emergency dam grouting. Another earth dam in south part of South Korea called Women Dam, found a leakage and the sinkholes on the dam. So when I arrived over there, we're dealing with authorities. They want me to provide the physical and the mathematical models of your fix. That's kind of a tough, how you handle that, especially when there's a leakage dam. So I told them, in the elastic subspace, I will have some numerical model. We can have some we'll have some theoretical solutions. And in the sand, more Coulomb type of the material, we may give you some numerical solutions. And honestly speaking, for your dam, I really don't know where the sinkhole development, where the loose soil zone, and which direction the water flow. So I told them, if you gave me a physical numerical model of your sinkhole, I may thinking of do some of the research and the modeling for the solutions. So this is really, we need to understand what we don't know. That is a fundamental, the training and habit of a geotech engineer we need to face. So you have to learn from the site. So we provide a similar solutions like rock pack will teach us to do in Bennett Dam. We run the primary, we run the secondary, we run the tertiary type of the grouting. I even colored each face of the grout, try to trace where there's a sinkhole, what is a cavity, and where they're interconnected. Kind of a learn from the job. And when we fix the problem, we finally learn the distributions, the spatial distributions of this sinkhole and this chimney. So this is related. As a geotech engineer, we need to know all of the fundamentals, and also we need to build up scale through the mitigation work, like doctor treat a patient, to observe the response, and then you keep treatment until the problem fixed. So it's fun to be a geotech engineer, especially when we to do some of the crazy job.
So I want to ask about another time that I think you probably did have to step out of your comfort zone. You mentioned it earlier, and I noticed from your LinkedIn bio, you came straight from undergrad in China to South Dakota School of Mines for grad school. I mean, this is not Berkeley. This is not University of Michigan. This is not New York City. This is South Dakota. Like, what was that transition like for you? What was the hardest thing about it, and what made you finally feel like you were at home?
When I was in China, when I graduated, I did involve quite some of the work as an engineer to run quite some of the modeling, mainly on the structural engineer side. This static and dynamic strain stress distributions of pressure vessel, and also the building seismic response. The things that bring me the interest is, or the challenge is building has the foundations. And during the big earthquake, there's a soil interact of the building foundations. That generates me some of the interest to the soil. The mechanics from structure go down to the soil. So this experience in South Dakota School of Mines, especially through Dr. Sancho Bang, my advisor, really opened my minds and also teach me how we can use this fundamentals of mechanics to the soil. So lead me to get into this industry, guide me to this, the soil behavior, and also this kind of especially from soil mechanics point of view, this interactions between the structure to soil. So that experience, I think, is very important. Training and learning, I'm kind of gradually adapted, from a more structural engineer mind to the geotech engineer mind.
So now another thing we make everybody do on Director's Cut is think way back, as far back as you can in some cases. And so, Lisheng, what's the first vacation you remember taking? The earliest one in your life?
Well, as an engineer, especially engineer in the contractor side, we really don't have complete vacations because always need to do something. Yeah. Because I remember when I do my vacation in 2003, really after a big project, I want to relax. And after the project, actually in Canada, really hot, and you want some place to cool down. So I went to Alaska, went to the Denali National Park, and take a train ride, really have fun. But also, I have many of the phone calls related to the job. Yeah, so it's all my memory of my vacations is never have a vacation not related to work.
The other question we ask everybody when they come on the show is, how did you first get involved in ASCE and then GI?
Yeah, that's as soon as I come to America in South Dakota, the professor said you better to join ASCE, start with a student member, that you can open your eyes, not only what the professor doing, and also to understand the industry. And also have fun. In South Dakota, I'm there short, only 11 months for my master's degree. I joined the student, the concrete canoe competition. That's a fun work of the ASCE, and we put some of the fibers into the concrete and try to increase the strength and also minimize, that micro crack maybe cause a leakage of the boat. Yeah, so that's a fun work. But the real GI involvement is in mid-90s when I'm in North Carolina. By that time, NC State hosts a grouting conference. And by that time, people use, the projectors use a real slide. And I was the guy to load each of the slide deck to run the project and then push the next for the presenters. But that kind of conference, I really early understand what the GI doing. And also the first time I get directly in touch with a big name like Donald Booth, like Bill McCuson, Royal Borden, understand what they're doing, what they're thinking, and how they present their work from the beginning, from the fundamentals, from unique things, and then present the solutions and the result. That kind of is excellent in my early times of training to follow these big names, understand their way of thinking and their ways to propose the solutions of the challenge job. Yeah, I learned a lot from GI and ASCE.
That's the right answer to close with there. I like that. Shortly after you graduated from NC State, you moved to California. I want to talk a little bit about the GE credential now, because I think to a lot of people in the rest of the country, they see that and they think, oh, it's kind of weird that California has its own separate credential. And sometimes people will even ask, what is that? They don't know what it is. You have the GE credential. Can you talk a little bit about it, why it's important and what it means to you personally to have it?
I think GE is a big step towards, experienced geotech engineer, because in California, GE will have 8 hours exam. Yeah, I took the GE exam, I think in year 2000 or 99. But that's a kind of a long culture, 8 hours to keep writing. Yeah. Almost wrote a whole book. But I think it's worthwhile. When people attend this PE exam or the EIT exam, it's the fundamentals, mainly focus on the fundamental of the engineering, especially more focused on the structural engineering. But when you really go to the details, especially for the geotech challenge, this exam, I have an analogy again. GE exam more like a doctor or physician's exam. When you go to that specialty, it's just kind of a check. Did you really understand the friction angle of the soil? And also how you understand this pile-soil interaction and how you handle a liquefaction case. I think it's important because in the geotech, it's not as careful, as a thoroughly codified as a structural engineer. So you really need to know the ways of the thinking, how to do the proper site characterization, like doctors or diagnosis of the patient, how uses indirect testing result to interpolate this soil true behavior. This GE, I think, is a qualification. When you pass this, they understand how much of the knowledge and the capabilities you can handle this kind of highly variable soil conditions. And maybe one more suggestion for a few GE exam, I strongly recommend we may add some of the statistical element. The statistics are very important tools for us to quantify the variables of the soil. And with a statistical mind will guide us to do a better job and also more cost-effective solutions to treat this highly variable condition. I think for the physicians so far and the surgeon, in their medical training, statistics is a required class. And also I understand quite some university graduate school for the geotech program, they now require the student to take a statistics class. I think that's also the future of the geotech engineer.
Oh, that was great. Thanks for that. And of course, for everybody watching, we'll put some information in the show notes below where you're watching this about the GE certification so that you can find out more. And if you're in California and you don't have it yet, you can look into pursuing that. We have 3 questions left. A couple more fun ones, and we gotta, well, they're all fun, really. That's what the show is about, right? What song or TV show always makes you change the radio station or the TV channel?
Well, I'm not regularly to watch TVs. And also nowadays with a cell phone, don't even to go to the radio channels.
Yeah.
But with that's kind of the new habit of the new culture that people can select the things and then to learn the things are more focused. Yeah, I'm kind of a maybe old-fashioned way like classical music, and also like some science and exploration channels or that kind of the topic in YouTube or some of the social media. Yeah, that's kind of a hobby.
Do you listen to music while you work? Can you listen to music while you work? I know a lot of people it just is totally distracting to them, but I'm the opposite. I almost need it all day long. What about you?
In general, I don't. Yeah, because in my work, I have lots of the communications and make phone calls. And also, in general, in the work, I need a focus. But other than work, do some household things, cooking and the things. I prefer to have some of the background music.
Yes, I need it all day long. I couldn't do it without it.
Yeah, I even to modify and put some of the speakers underneath the setting, so I have this kind of environmental sound in my house. Yeah, I'm kind of have a hobby to do some of the electronics. Even in my college education, I took quite some of the electronic classes and analog circuitry, digital circuitry, and kind of soldering, and to make some of the radios, amplifier. Yeah,
wow.
That's kind of the hobby.
So if anybody in GI needs some help with their home theater system, it sounds like you're the guy to call, Lisheng. So maybe you should start charging and advertise at conferences and stuff. That would be pretty good. When I started preparing for this interview, something that I totally forgot about is that GI kind of sponsored a ground improvement trip to China in 2018. And you went on that trip, and Jim Collin went on that trip, and Ji Han went on that trip, and a bunch of other people. So I wanted to ask you a little bit about it. The report that came out of that, which we can also link to down in the show notes. What is the most exciting to you about the new technologies that you see coming from China, specifically in ground improvement? What can we learn from them here in the States?
Yeah, I really appreciate that kind of opportunity, ASCE GI, to host that trip and go to China in the early summertime of 2018. Mainly we visit the south, the east part around Shanghai and adjacent Zhejiang province. China produces more than half of the world's cement and steel. And the majority of that amount used for the construction, and quite a lot applied below the ground surface. So it has a huge, the magnitude scale is more than the whole Western world. So they have a lot of experience and also lessons learned. And also my work is more focused on the ground improvement. The unique things the Chinese do, and also the kind of one of our focus over there, they use massive vacuum consolidations in their dredged land to treat a very soft, cohesive soil. This kind of a smart application, and also conforming to the fundamentals of Tasarki soil mechanics. When you apply the vacuum, right, it's homogeneous pressure. So that kind of soil never has a bearing capacity failing. So you don't need to do the stage type of the loading, and you can, to trigger the consolidation very quickly. And also they combine some of the new technologies like electro-osmosis, like dynamic compaction, combined with vacuum consolidation to treat some of the siltier soil to further accelerate and this kind of the soil consolidation. It's very unique. Yeah, that's the things we learned, and we put a report of this US ASCE, and we put that, I think, is saved in the ASCE website. And together with many things else, like soil mixing applications, rigid inclusion applications, there's a very deep diaphragm wall. Over there, we learned a lot. And also some of the combinations of technology, the soil mixing together with a tieback, that's for the deep excavation support. So that is kind of eye-opening. So we also put that into the document. They have quite a lot of experience. I think we need to enhance, this technical exchange worldwide, and also bring the knowledge and experience outside to U.S. And we share this and improve the whole industry.
Oh, that's great. Now, I have to ask, again, we'll link to that report down in the show notes below. I do have to ask a follow-up question, because one of the things that Jim talked about after that trip was the food that he ate. And everything on Director's Cut comes back to food, sports, and music. Those are the three categories. And then we talk about some other stuff too. What is the best thing you got to eat on that trip?
Actually, during that trip, because I grew up in China and know the Chinese language, and I was actually the interpolator of this, translator of this team. Where I'm interested is kind of a special fruit. I don't know how to spell that in English. It's kind of a sweet and sour fruit. And one of the, I think that's in Zhejiang province. And when we had this technical session, we do the presentation, they serve this kind of the fruit. So I was really busy to eat that fruit and also to do translate of the whole session. It's tasty. In China, we call it yang mei. That kind of fruit, also in this ancient Chinese, novels or the Chinese articles, 1,000 years ago, had already had this kind of fruit. Actually, I never tasted it before when I was in China, and only I learned from this 2018 ASCE trip, and the first time I tried it. It's really tasty.
So another great thing that came out of that trip. That is fantastic. I'm going to hunt this down and put more information about it down below again. The final question we have for you, Lisheng, and we might end up talking about food on this one too, so I'm going to apologize in advance. Your office is in downtown San Francisco. I think it would be hard to find somebody in the United States that does not think of San Francisco as one of the coolest places to visit and one of the coolest places to see in the U.S. What is your favorite place in San Francisco?
Well, I'm the engineer, always has curiosities. Yeah. Close to my office, 2 blocks away, is Millennium Tower. That is excellent case history. I think should be for the whole generation of the geotech to understand how it's built and how it settles and how it's mitigated, and also the follow-on monitoring and also the trend. I think that is a very, very good learning place, or the training place, a training ground for this whole generation of geotech engineer. Understand how you characterize the soil behavior, how you interpolate this behavior heavy load applied to certain kind of soil, and understand the time effect, understand the group effect of that pile. So very important. And my office is 2 blocks away from Millennium Tower. So during the mitigation work, every day I pass that job site twice, in the morning and in the evening, to see this kind of operations and its mitigation. This is really a fun, not only fun, and also a learning process through this tower construction and mitigation.
So that was obviously a huge news story that went way beyond the engineering community. Do you think it helped or hurt that it was in such a public place where, like you said, people are walking by this all day watching the work? If you're not an engineer, you probably don't have a really good understanding of what's going on. But this was also, from a public relations standpoint, Millennium Tower thing has been a nightmare. Do you think it helped or hurt that it was so out there and that everyone could see the work that was happening on this?
Well, for the engineer, especially, the engineer in the public, especially for the young engineers, this is an excellent case study, and we need to learn it. And also, as I mentioned before, Tasarki always right. Yeah, we need to understand the mechanism of this soil behavior. Yeah, when you apply too much load to certain cohesive soil, you have the time effect of the consolidation that we observed of the building settlement and also the settlement curve. Yeah, according that to the fundamentals and the uses, I think will be a very good case study for the young engineers in their graduate school, learning, and maybe in the future in the GE exam.
Now, before we go, super important question. 1 or 2 restaurant recommendations for people going to San Francisco. Where should they eat? What are your favorite places?
Quite some of the locations I recommend. If you like Chinese food, there's called Harborview. That's at the Embarcadero, very close to the subway station over there. You can Google it. It's quite some unique kind of Chinese flavored food over there. That's my recommendation.
Fantastic.
And also, not far away from Millennium Tower, you can visit 2 places at the same time.
That's good. That would be a good little afternoon there. And that's great recommendations. And see, we always find a way to put food into Director's Cut, right? Lisheng, you made it through all 10 questions. You did a great job. I think there should be nobody out there now intimidated by engineering mechanics. They learn a little bit more about the GE credential and so much more today. So that was fantastic. For our viewers, if you liked what you saw and you're here at the end, so you probably did, again, click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Lisheng, thank you for doing this. I hope it was fun.
Thank you, Brad. Yeah, this is really fun conversations.
Fantastic. And for all of our viewers, we will, of course, see you in another 7 days with a brand new episode of Director's Cut.